Hello, in this video, part 2 on limits, we're going to look at what happens when you can't plug it in. Hopefully by now you're pretty familiar using limits on questions where it does evaluate nicely, and you're realizing that a limit is very similar to function evaluation. You just plug it in and you get your answer. But let's look at an example, say the limit as x approaches 0 of 2x over x. Well, if you were to plug that in, you'd get 2 times 0 over 0. 2 times 0, of course, is 0, so 0 over 0. We know we're not allowed to divide by 0, and so we're stuck. We're back to the same situation we had before. It seems like this whole limit idea isn't helping us, because I want to plug in 0, but I can't, because I get, well, the 0 on the bottom. But if you look at this, does there seem to be some type of situation you might want to apply here? Is there some type of math operation, some type of simplification you could do to make your work a little bit easier? And hopefully you see it, you could cancel out the x. Well, we would rewrite this then as the limit as x approaches 0 of 2. And the limit of a constant, of course, is just the constant itself. And there you go. No dividing by 0. We got our answer of 2, easy peasy. And this is what limits are. They're like function evaluation when it plugs in. But when you can't plug it in, you can often still find the limit. And so what you want to think of is that limits are more powerful than function evaluation. They're like function evaluation when it plugs in, but when they don't plug in, they're actually more powerful and more useful. So let's look at some examples of what to do when you're trying to do a limit and it doesn't plug in. So here's your general method for finding the limit as x approaches a of f of x. And in particular, we'll look at the basic case where you have a polynomial over a polynomial. Well, option number 1 is just P of A and Q of A, meaning you tried to plug in A on the top and the bottom. Both of them were non-zero. If that's what happens, well then we're done, because we plugged it in and we got a non-zero number on the top and a non-zero number on the bottom, so we're good to go. That's just a plug it in case. Now if you plug it in and get 0 on the top and a non-zero number on the bottom, like, for example, maybe 0 divided by 4, well that's just going to be 0. Because you can divide by 4. If you have 0 cookies split up among 4 people, you still have everyone getting no cookies. And so both of these cases are actually just a plug it in case. Plug it in. No big deal. But sometimes, like in our example we just looked at, you get a 0 on the top and a 0 on the bottom. This is called an indeterminate form. 0 over 0, of course it's undefined, but we can say more than that. And in calculus, we call something like this an indeterminate form. And what it means is we need to do more work. We need to do something to our limit to try to make it work. Now, what we're going to do is what we're going to spend most of the lesson looking at, the different techniques. But we need to do something, some type of work. Now, number 4, we're going to save for a later video. If the top is non-zero and the bottom is 0, then we're going to use one-sided limits, which we'll look at later. So let's look at an example here. The limit as x approaches 1 of 3x minus 2 over 2x plus 7. Well, the first thing you should always do is try to plug it in, because we hope that the limit plugs in. That would be nice if it plugged in. So you get 3 times 1 minus 2 over 2 times 1 plus 7. So that's going to be 1 over 9. Well, it plugged in. So there you go. There's your answer. We got 1 over 9. 1/9 is the answer to this limit. Now let's try doing the same technique on something like this. Limit x approaches 3 of x squared minus x minus 6 over x squared minus 4x plus 3. So again, we plug it in because we hope that it plugs in. 3 squared will be 9 minus 3 minus 6. 3 squared is 9 minus 12 plus 3. 9 minus 3 minus 6 is 0. 9 minus 12 plus 3, that's also 0. We have, right here, 0 over 0, which means we need to do more work. We need to do something to this limit. We need to find a way to evaluate it. But what could we do? What possible work could be done? Well, think about it for a minute. If this limit wasn't here, and you had this over this, what might your teacher ask you to do? What might be the math skill that would be useful in this situation? What have you been doing for 3 years in math class? Hopefully, your teachers have been telling you to factor. They've been saying factoring is important, factoring is useful, you're going to need to know how to factor. Well, let's try factoring. Let's see if that's something useful. So we still leave the limit out front because we haven't done a limit yet, so you write limit. So we're looking for two numbers that multiply to give -6 and add to give -1. Looks like x minus 3, x plus 2. Multiply to give 3 and add to give -4, that's definitely -3 and -1. So x minus 3 and x minus 1. Well, it looks like something cancels. Again, we haven't done a limit yet. We're just working on the inside portion, so we have to keep writing limit. We have x plus 2 over x minus 1. All right, well, let's go ahead and try to plug it in now. So we get 3 plus 2 over 3 minus 1, so 5 over 2. There we go, there's our answer. And so what we did here, of course, was factoring. We need to do more work, and when I say that, I mean you need to do some kind of math work. In this case, the work that you needed to do was to factor. And so you might have asked yourself, all those years, you were being told, factor, 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 and you were like, why? Why do I need to factor? Well, this right here, this question, this limit, is the reason you've been factoring for all of those years. If you've wondered, why am I factoring? What's the point of factoring? When am I ever going to use this? This is the moment right now. This is the moment you've been preparing for. This question is why you need to factor, why you've been working on that skill so long. And so let's go ahead and do another one. Here's a question. We've got two polynomials. If you notice, neither one of them have a leading 1, so definitely some tricky factoring. Go ahead and try to plug it in. Let's see. Maybe it plugs in after all. You hope, right? It's always your first guess. Your first attempt, your first method is to try to plug it in. So 2 squared is 4, so 2 times 4 minus 10 plus 2 over 5 times 4 minus 14 minus 6. Well, that's going to give me 10 minus, oh, that's 0 in the top. 8 minus 10 plus 2 is 0. And 20 minus 14 minus 6, that's 0. Yep, we've got to do more work. Do more work. Well, go ahead and pause the video and try to do that work. Try to factor these two polynomials. Try to cancel something. See if you can actually get the correct answer. All right, so I'm assuming you gave it a try. Here's the following factoring. So I'll do it on the side here just to make sure. We would do 2x squared minus 4x minus x plus 2. So you'd get 2x, x minus 2, minus 1, x minus 2. So x minus 2 times 2x minus 1. And then for the other one, it'll be 5x squared minus 10x plus 3x minus 6. So 5x, x minus 2, plus 3, x minus 2. So x minus 2, 5x plus 3. All right, so those are our two factored forms. We've got x minus 2, 2x minus 1, x minus 2, 5x plus 3. All right, cancel those out. And we still have to keep writing limit each time because we haven't done a limit. You always write limit until you actually plug something in. So we've got 2x minus 1 over 5x plus 3. And once you cancel something and do some more work, it's always a good idea to try to plug it in. It doesn't always work. Sometimes you need to do a lot of work. But if you have canceled something, it's a good time to try plugging it in. So we try. 2 times 2 minus 1 over 5 times 2 plus 3. So that'll be 3 over 13. There we go. We have our limit. And again, the skill that we needed that was so crucial was factoring. Without factoring, this limit would be impossible, but with factoring, it's not too bad. So let's try another example here. We have the limit x approaching negative 2 of x cubed plus 3x squared minus 4 over x squared minus 4. Now, in this case, we, of course, should always try by plugging it in. We should always hope that the limit plugs in, just in case it does. I don't think it will, but we'll give it a try anyways. So if I plug it in, I'm going to get negative 8. That's going to be plus, well, 4 times 3 is 12, minus 4, over 4 minus 4. Yep, that's looking like 0 over 0 to me. Well, we've got to do some more work. We have to do something here. And the bottom, I think, is pretty easy to factor. We can go ahead and see that difference of squares right away. So limit x approaches negative 2 of x minus 2, x plus 2. But the numerator is a little trickier. Because it's degree 3, we have to use synthetic division. And so you have to try all the possible roots. Well, for that 4, we've got a lot of possible roots, right? This is going to be plus minus 1, plus minus 2, plus minus 4. So you've got to check those roots and find which one works, so we can go ahead and factor that top. So go ahead and pause the video and see if you can factor that numerator. All right, assuming you gave it a go, I'm going to give you a bit of a hint here. You don't actually have to check all of those. And here's why. When we plugged the number negative 2 into the top, we got 0. That's what started this whole journey, because we got 0 over 0 and we had to do more work. But what that means is the number negative 2 is a 0 of the numerator, which means because it gave us 0, the number we need to check for synthetic is negative 2. In fact, we don't really have to check it. We already know it's going to work. So let's do a little synthetic here. We've got 1, 3, 0, and negative 4. We're going to use our negative 2. So we'll get 1, negative 2, 1, negative 2, negative 2, 4, and 0. Which tells us that our factored version would be x plus 2, and then x squared plus x minus 2. All right, well, we have that, and we can put it on the numerator right here. So x plus 2, x squared plus x minus 2. Now, some of you might have factored further, and you're welcome to factor this further. This might factor even more. But our goal isn't necessarily to fully factor everything. Our goal is simply to get something that cancels, and then to try eventually plugging in the limit. So let's go ahead and see what we have now. We have the limit x approaches negative 2 of x squared plus x minus 2 over x minus 2. Well, let's plug it in. We'll get 4 minus 2 over negative 2 subtract 2, which is equal to, well, we're going to get 0 over negative 4, which is just 0. And that's totally fine. You can get 0 as your final answer. Again, 0 is a perfectly acceptable answer. It's just 0 over 0 is what's incorrect. All right, there we go. We got our limit. Now let's try this example here. This is the one we started the first video with. If you remember, the answer for this one was supposed to be 2. And we figured that out by trying on our calculator. But would there be a way to do it without our calculator? Would there be a way to use algebra to get that number 2? I mean, you could try to plug it in, but you're going to get 1 minus 1 over root 1 minus 1. 0 over 0, you're going to need to do more work. So it's not entirely clear what the work would be. You might look here and say, oh, I could factor, but there doesn't really look like any factoring I could do. You could say to yourself, well, maybe synthetic, but well, no, that would be part of factoring. And so you kind of scratch your head and you say to yourself, what skill could be useful here? Pause the video and see if you can think of a math skill that might be useful. Well, hopefully you thought about it for a little bit, and maybe you came up with the right skill. The skill in this case is rationalizing. What we're going to do is, if you notice, there's a root in the bottom. And so we can go ahead and multiply by root x plus 1. Root x plus 1. Let's go ahead and see what we get. That'll give us limit x approaches 1. And we're going to get, well, when we rationalize, we're never going to multiply the other portion out. So we're going to leave this as just multiplication. And the bottom we're going to rationalize. So we get x minus 1. Again, if you're a little bit unsure about that multiplication, I'll do it on the side over here. So we've got root x minus 1, root x plus 1. So first is root x times root x, which is x. Outside is root x. Inside is negative root x, and last is negative 1. So those middle terms always cancel out when you rationalize, and you just get the first term and the last term from your distribution. Okay, so we have x minus 1 and x minus 1 on the top and the bottom. Let's go ahead and cancel those out. That gives us the limit x approaches 1 of root x plus 1. Well, we did something, so let's try to plug it in. Root 1 plus 1, which is, of course, 2. And there we go. We're getting our 2 that we knew was supposed to be the answer initially. But we're not getting there by rounding 1.999 or using our calculator. We're getting a nice, pure, beautiful 2 by doing the algebra. And in this case, it's very important. You've been rationalizing for many, many years. And hopefully your teachers explained to you, well, you have to rationalize because, well, you don't want roots on the bottom. But you might have said, well, okay, why don't I want roots on the bottom? And they might have just said, well, because it's improper, it doesn't look nice, or you're supposed to rationalize. And those are good reasons, but they sometimes feel a little bit hollow. It's like, why can't I have a square root on the bottom? There's no reason I can't. It feels fine. It feels just maybe the square root wanted to be on the bottom. And so that reason for rationalizing, personally, it never sat the best with me. And this question here provides a much better reason for why you rationalize. In this question, you don't rationalize because someone tells you you can't have a root on the bottom. You rationalize because it's the work you need to do to solve the limit question. In other words, in this case, we don't rationalize because we have to. We rationalize because we want to. And that's something that's going to come up in calculus as we do these limit questions. You're going to use the math skills not because you have to, but because you want to. Calculus is an excellent application of all those pre-calculus skills that you've worked on so hard. So let's do a real big rationalizing question. In this one, the root is on the top, but that's all right. We can still use the technique of rationalizing. So go ahead and see if you can work this question all by yourself. Give it a try, and then I'll work through the solution. So I'm assuming you give it a try, and hopefully you realize that it is indeed giving you 0 over 0. It's good to check. So when you plug it in here, you get 1 minus 2 plus 2 under the square root, minus square root 1 over 1 squared minus 1. That's going to be 1 minus 1 over 1 minus 1, which is 0 over 0. So we've got to do something. We've got to do more work. And in particular, we're going to rationalize. So we'll get x squared minus 2x plus 2 plus root x. And then root x squared minus 2x plus 2 plus root x. Now, like I mentioned before, when you do these rationalizing steps, you don't want to multiply out the top. You just want to, or the bottom, I should say. You don't want to multiply the one that's not being rationalized. So in this case, the rationalizing is happening because of the top. So this portion you want to multiply out. But the bottom here, just leave it unmultiplied. Just write it down as multiplication, but don't actually do the multiplication. So this will be x squared minus 2x plus 2 minus x over x squared minus 1 root x squared minus 2x plus 2 plus root x. All right, so we should probably simplify the numerator. We could write that as x squared minus 3x plus 2. And if you notice, this looks pretty tempting. I'm going to factor that down as a difference of squares just as I'm going through this. So x squared minus 3x plus 2, x minus 1, x plus 1, root x squared minus 2x plus 2, plus root x. Now, rationalizing isn't enough. I need to cancel something. So this numerator, I should probably factor that. So thinking about it, two numbers that multiply to give 2, add to give negative 3, negative 1 and negative 2 look like they'll work. So let's try that out. Limit x approaches 1, x minus 1, x minus 2, x minus 1, x plus 1, root x squared minus 2x plus 2, plus root x. So we can cancel these. Well, once we've canceled something, it's usually a good idea to try plugging it in. It might not work, but hopefully it does. Hopefully we've done enough work to make the limit actually evaluate. So let's see if we can give this a try. Let's see if we can plug in x equals 1. So we're going to get 1 minus 2. That's not 0, so looking promising. 1 plus 1. And then square root, well, that'll be 1 minus 2 plus 2 plus root 1, which will be negative 1 over 2. And then root 1 plus root 1, so 1 plus 1. That's negative 1 over 1 plus 1 is 2, and 2 times 2 is 4. Hey, there we go. We got a number in the end. So the limit would be negative 1/4. Determine the following limit. Limit x approaches 1 of x squared plus x minus 2 over x minus 1. So go ahead and pause the video and give it a try. All right, so hopefully when you plug it in, you see that you're definitely getting 0 over 0. A little factoring is in order, so x minus 1, x plus 2 works. And that means that we can go ahead and cancel out the x minus 1s. And when we plug that 1 in, we're going to get 1 plus 2, giving us the correct answer of 3. Now we're going to do one more question here before we end the video. I want us to look at the following limit. H approaching 0. First off, we can do limits with letters other than x, of course. H plus 2 squared minus 4 over h. Well, if we plug this in, we're going to get 0 plus 2, which is 2. 2 squared is 4, and 4 minus 4 is 0 over 0. So this is definitely 0 over 0. We need to do some more work. And what work could we do? Well, I think expanding is a good technique in this case. I think that h plus 2 squared, I think we should actually square that out. And if we do, remember, h plus 2 times h plus 2, that'll give me h squared plus 2h plus 2h plus 4, so h squared plus 4h plus 4. So we get h squared plus 4h plus 4 minus 4. Well, we can cancel out those 4's, which gives me a limit h approaches 0 of h squared plus 4h over h. Now we can't plug it in yet because if we did, well, this would give me 0 plus 0 over 0. That's still 0 over 0. But we could go ahead and factor out an h from the top. That'll give me a limit h approaches 0 of h times h plus 4. We could cancel out those h's, which will just leave us with the limit h approaches 0 of h plus 4, which is 0 plus 4 or 4. There we go, another limit successfully completed, and of course using those skills from pre-calculus. So for homework, please try the limit worksheet A and B, and then also page 102, number 3 through 32. Again, for these textbook questions, the answers for all of the odd questions as well as the solutions are available. The answers are in the back of the textbook and the solutions are in your solution manual. The even questions don't have answers or solutions, but you can always go ahead and type the questions in online, and you can usually find answers to them using any of the online websites that we recommended in the course. So hopefully you enjoyed this video, and as always, thanks for watching.